Captions in English, please. So this is the fourth video of chapter 6, and we'll learn how to balance chemical equations that have polyatomic ions on both sides of the equation. So when balancing reactions that contain a polyatomic ion on both sides of the reaction, you can balance the polyatomic ion as a unit rather than breaking it apart into separate elements. You will see that it makes it a lot easier to balance and quicker. For example, we have cadmium plus nickel nitrate in a solution, produce nickel, the solid metal, and the cadmium nitrate aqueous solution. So here we have nitrate, salts of nickel with nitrate or cadmium with nitrate. So when you are ready to count your atoms on both sides of the arrow, you count one cadmium on the right, one cadmium on the left, one nickel on the left, one nickel on the right. And then there is 3 nitrate on the left because we have the nitrate and then parentheses around it and 3. So the 3 here means there is 3 of what's in the parentheses. And so there is 3 nitrate in the nickel nitrate here. And then in the cadmium nitrate, there is 2 nitrate because we have parentheses around the nitrate and then a subscript of 2. So you don't need to separate the nitrogen and the oxygen. It's much easier to keep the nitrate together because it stays as a unit, from the left side to the right side. So here cadmium and nickel are balanced and the nitrate are not. So we have 3 on the left and 2 on the right. And when we have, 3 on the left, 2 on the right, or vice versa, the least common multiple of 2 and 3 is 6. And that's how you want to balance this. So you should balance the reaction so that you will have 6 nitrate on each side. So for this, we will need a coefficient of 2 on the left side because we already have 3 nitrates, so times 2. And then on the right side, we'll need a coefficient of 3 because we have already 2 nitrates, so 3 times 2, it's going to be 6. So on the left side now we have 2 times 3 nitrate, it's 6 nitrate. And on the right side, we have 3 times 2 nitrates, and so that's 6 nitrate on the right side. So this way the nitrates are balanced. However, when you place those coefficients, it also changes the number of cadmium and nickel. You can see on the left that now you have 2 nickels on the left instead of 1. And on the right, you have 3 cadmium instead of 1. So we need now to balance cadmium and nickel. So we have 3 cadmium on the right, 1 cadmium on the left. So let's balance by making it 3 cadmium on the left by having a coefficient of 3 in front of cadmium. And this way it changes the number of cadmium on the left to 3. Nickel, we have 2 nickels on the left, 1 on the right. So let's make it 2 on the right by having a coefficient of 2 in front of the nickel. And that's making it 2 nickels on the right. And this way we have the same number of each atom on both sides. So the final answer is 3 cadmium plus 2 nickel nitrate salt gives 2 nickel and then 3 cadmium nitrate salts. And you can check that there is the same number of cadmium, nickel, and nitrate on both sides. So let's do a concept check here, and you need to pause the video to try this on your own before you watch the answer. So we have solutions of potassium nitrate and aluminum fluoride that are formed when aluminum nitrate solution reacts with a potassium fluoride solution. So be careful here. The sentence starts to enumerate the product and then finishes with the reactant. So when aluminum nitrate reacts with potassium fluoride, these two are the reactant. So let's start with aluminum nitrate. Aluminum is a metal from group 3A, but it's a type 1 metal, so it's always 3 plus when it's an ion. Aluminium 3 plus and nitrate. Nitrate is one of these polyatomic ions you need to remember, and it's NO3 negative 1. So there is 1 negative charge for 3 positive charges. So you will need 3 nitrates to cancel the 3 positive charges from the aluminum. So the formula is Al and then NO3 3 times, because you want 3 nitrates to get 3 negative charges to cancel the 3 positive charges on aluminum. And here it says it's a solution. So this means it's aqueous. You want to write that it's aqueous. It reacts with potassium fluoride, also a solution. Potassium is K, fluoride is F. K from group 1A makes K plus ions, and F from group 7A makes F minus ions. 1 positive charge, 1 negative charge each, and so that's mean the formula, the neutral formula is Kf. And that's aqueous because it's a solution. So together they react to form potassium nitrate. Potassium is again K plus, nitrate is NO3 minus. So you see that 1 K and 1 nitrate will make a neutral formula. That's also a solution, so it's aqueous. And aluminum fluoride. Aluminum is Al3 plus. Fluorine is F minus when it's an ion, the fluoride ion. So we have 3 positive charges in the aluminum and only 1 in the fluoride. So we will need 3 fluorides to cancel the 3 positive charges on the aluminum. So it's going to be AlF3. And it's a solution, so it's aqueous for the state of matter. So now that we have our formulas of reactant and product, let's count the number of atoms on each side. And here we have 1 aluminum on the left, 1 aluminum on the right. What comes next is the nitrate. You see how we have nitrate on the left and nitrate on the right. So we can keep it together because the ion stays together and it acts as a unit or reacts, and stays the same from one side to the other. So we have 3 nitrate on the left, 1 nitrate on the right. And then 1K, 1 potassium on the left, 1K, 1 potassium on the right. And fluorine, 1F on the left and 3 fluorine on the right. So when you have polyatomic ions in your chemical equations, that's the one you want to start with when you're balancing. It's always start with the polyatomic ions. And here we have 3 nitrate on the left, 1 nitrate on the right. So you want to make it 3 nitrate on the right by having a coefficient of 3 in front of the potassium nitrate. So this changes the number of nitrate to 3 on the right. However, when you put the 3 in front of K and O3, it also changes the number of K. And now we have 3K on the right. So that changes the number of K on the right. And so let's make it 3K on the left. So apply a coefficient of 3 in front of Kf. And this way we will have 3 potassium on the left as well. But the 3 in front of Kf changes the number of F. So it changes it to 3 on the left. So, and it happens we have already 3 F on the right. So that balances the fluorine. And that's it. It is balanced. The final answer is that. So we can see that we have 1 aluminum on the left, 1 aluminum on the right. 3 nitrate on the left, 3 nitrate on the right. 3 potassium on the left, 3 potassium on the right, 3 fluorine on the left, and 3 fluorine on the right. That's balanced. Let's do another concept check. Again, pause the video before you watch the answer. Ammonium chloride solution will react with calcium hydroxide solution to form solutions of calcium chloride and ammonium hydroxide. So let's find the formulas of these reactant and product. So ammonium chloride will react. So that's a reactant. Ammonium is one of those polyatomic ions you need to learn, and that's NH4 plus. The chloride ion is Cl minus because chlorine is in group 7A, 7 minus 8, it's -1. So ammonium for NH4 plus and then Cl minus, one of each will cancel the charge on the other. So that's the formula here, NH4Cl. AQ because it's aqueous, it's a solution. Will react with calcium hydroxide solution. So calcium is a Ca from group 2A, it's a 2 plus ion. The hydroxide ion is one you need to learn, it's OH minus. It's a polyatomic ion that you need to learn, and that's OH minus. One negative charge. Calcium has 2 positive charge. So you will need 2 hydroxide per calcium to cancel the charges and make this a neutral formula. So that's going to be CaOH 2 times. So you need 2 hydroxide per calcium. And that's also an aqueous solution, so AQ. It forms solutions of calcium chloride. Calcium chloride, it's so Ca is 2 plus, Cl is -1. So we need 2 chlorine for 1 calcium. So 2 chloride ions for 1 calcium, and that's going to make it CaCl2 to be a neutral formula. That's another aqueous solution here. And then ammonium hydroxide, also a solution. Ammonium is NH4 plus, hydroxide is OH minus. 1 positive charge, 1 negative charge. So you just write them next to each other, and that's NH4OH. And that's an aqueous solution, so AQ. So now that we have the formulas for the reactant and product, let's count the number of atoms of each kind, or polyatomic ions. And here we can see we start with NH4, which is the ammonium. You want to recognize this as the ammonium. So we have 1 ammonium on the left and 1 ammonium on the right. Chlorine, 1 Cl on the left, 2 chlorine on the right. Calcium, 1 calcium on the left, 1 calcium on the right. And then OH is the hydroxide polyatomic ion. You want to recognize it here. And so you count 2 hydroxide ions on the left and 1 hydroxide ion on the right in the ammonium hydroxide. So when you have polyatomic ions, you want to start by balancing polyatomic ions. Here the ammoniums are already balanced, so we need to move on to the hydroxide. We have 2 hydroxide on the left and 1 hydroxide on the right. So let's make it 2 hydroxide on the right by having a coefficient of 2 in front of the molecule that has the hydroxide, and that's the ammonium hydroxide. So let's put a 2 in front of NH4OH. So this will make it 2 hydroxide ions on the right side, and we have already 2 on the left side. So that balances the hydroxide. However, when you place a 2 in front of NH4OH, it also changes the number of ammonium ions. And it makes it 2 ammonium ions here on the right. So we need now to balance the ammonium. So we have 2 on the right, we want 2 on the left. So let's make it 2 on the left by having a coefficient of 2 in front of NH4Cl. This way we have 2 ammoniums on the left, 2 ammoniums on the right. When you place the 2 in front of NH4Cl, it also changes the number of chlorine. And it makes it 2 chlorine now on the left. And we have 2 chlorines on the right, so that balances the chlorine. We still have 1 calcium on both sides. And so it looks like it's all balanced now. And so the final answer would be this. 2 ammonium chloride plus 1 calcium hydroxide gives calcium chloride and 2 ammonium hydroxide. And you see you have 2 ammoniums on both sides, 2 chlorines on both sides, 1 calcium on both sides and 2 hydroxide on both sides of the equation.